Debugging a monolith is relatively straightforward. A request enters the process, executes some code, and you can usually inspect the stack trace or logs to understand what happened. In a microservices architecture, that same request might travel through 10 or 20 different services running on different machines. Imagine an e-commerce checkout request. The API gateway, it calls the order service, which calls the payment service, which calls the inventory service, which talks to a database and publishes an event to Kafka. If the request takes 5 seconds, where did the time go? Distributed tracing solves this by giving the entire request a unique identifier called a trace ID. The very first service generates this identifier and propagates it to every downstream service through HTTP headers, message metadata, or remote procedure call contexts. Within a trace, every unit of work is represented by a span. A span records information such as its start time, end time, operation name metadata, and most importantly, its parent span. These parent-child relationships form a tree that represents the execution of the entire request. Suppose the order service calls both the payment service and the inventory service in parallel. The trace will contain 2 child spans that overlap in time. This immediately shows that the operations were executed concurrently rather than sequentially. Context propagation is one of the hardest parts of distributed tracing. Every service must forward the trace ID and span context to downstream services. If one service forgets to propagate the context, the trace becomes fragmented and you lose visibility into part of the request. Tracing systems then collect spans from every service and reconstruct them into a single timeline. This makes it possible to answer questions that logs alone cannot answer. Which service is the bottleneck? Which database query is slow? Which downstream dependency is causing retries and timeouts? Distributed tracing doesn't just show where a request went. It shows the causal relationships between operations across an entire distributed system. By turning thousands of independent log lines into a connected execution graph, it gives engineers a way to understand systems that are far too complex to reason about service by service.